Alright, so now we're on number 6 for test 5 test review. So in number 6, you have to determine whether the series converges or diverges. So to figure that out, you have to look at the R value. So the R value is the number that's being raised to the power if you're looking at summation notation. And then if you're given the sequence, like in C and D, then you take the second term and divide it by the first term to get your R value. Alright, so in A, our R value is 1/5. So 1/5 is in between -1 and 1. So that means that the series converges. In letter B, your R value is 3/2. 3/2 is not in between -1 and 1. So the series diverges. It might be helpful to draw the number line that I showed y'all. So -1, 1. So if your R is in between here, then it converges. If it's anything outside of that, then it diverges. Alright, so -3/2 is 1/2, so 1/2 would be over here, so it diverges. 1/5, so that would be in between here, so it converges. Alright, so we're given the sequence in C, so the way we find R is we take the second term, so -32, and divide it by the first term, 64, and we get -1/2. So -1/2 is in between -1 and 1, so it converges. Alright, and last one for number 6, let's look at D. So R equals, and to find R, you don't have to do the second divided by the first. You could do as long as you're doing the term divided by the term before it. So we could do 6 divided by -3. So 6 divided by -3 is -2. -2 is over here, so it diverges. So that's all you had to do for number 6. Alright, so let's look at number 7. So in number 7, you have to determine the common ratio of the infinite geometric series. So they give you the first term, and they also give you the sum of the series, and you have to find what R is. So in order to do this, we have to use the infinite geometric series formula, which is S equals A sub 1 over 1 minus R. So we're given S, so 5 equals, and we're also given A sub 1, so 4 over 1 minus R. So we can make this a 5 over 1. So then to solve, we will cross multiply. So that times that, and that times that. So we'll get 5 times 1 minus R equals 4. So 5 minus 5R equals 4. We're going to subtract 5 from both sides. So we get -5R equals -1. We're going to divide both sides by -5. So R equals positive 1/5. Remember, negative divided by negative is a positive. Alright, so let's look at B. So in B, we're given the series, or the sequence, and we're going to have to find the R value. So R equals -32 divided by 64. So r equals negative 1/2. No, I didn't even notice that. Alright, so since they give us the sequence, we can find the r value doing this. We don't have to use the sum formula. Although, if you want to use the sum formula, you can, just to make sure that r is in fact negative 1/2. So, we're going to use the same formula, so s equals a sub 1 over 1 minus r. So s is 128 over 3. So 128 over 3 equals 64. So a sub 1 is 64 over 1 minus r. So then we're going to cross multiply. So 128 times the quantity 1 minus r equals 3 times 64. 3 times 64 is 192. So we're going to get 128 minus 128r equals 192. So then we're going to subtract 128 from both sides. So we get negative 128r equals 64. So then we're going to divide both sides by negative 128. So we get that r equals negative 1/2. Alrighty, so that's number 7. So let's take a look at number 8. So in number 8, it says, describe how you know when an infinite geometric series converges or diverges. Give an example of each and use complete sentences. So how do you know if an infinite geometric series converges or diverges? So an infinite geometric series converges if r is in between negative 1 and positive 1. So remember the diagram I drew. So if r is in between here and here, then that means the series converges. Otherwise it diverges. Alright, so if it's in between negative 1 and 1, then the series will converge. Alright, so example. So let's say we have our first term, so a sub 1 is 2, and we need to have an r value that is in between negative 1 and 1, so you could pick anything that's in between negative 1 and 1. I'm going to pick 2/3. So I'll write this in summation notation. So we're going to start from the first term, so n equals 1, and we're going to go to infinity because it's an infinite geometric series. Our first term is going to be 2, so 2 times, and then our r is 2/3 to the n minus 1 power. So this is an example of a series that converges, or of an infinite geometric series that converges. Alright, so now let's talk about when it diverges. So an infinite geometric series diverges if R is less than -1 or greater than +1. So an example of this, so let's have summation from, starting with the first term, so n equals 1 on the bottom. We're summing to infinity. Let's make our first term, we'll make our first term 19. And let's make our R value, so our R value has to be either less than -1 or greater than +1. So I'm going to pick -2. So I'm going to have an R value of -2. So this infinite geometric series will diverge because -2 is less than -1. Alrighty, so let's look at number 11. So find the sum of all even numbers from 1 to 1,000. So the even numbers. So the numbers 1 to 1,000, so that's 1,000 numbers. We're only summing the even ones. So we know that half of the numbers are even and half are odd. So 1,000 divided by 2, because we're only summing the even ones, gives us 500. So our n, the number of terms, is going to equal 500 because the even numbers is only half. Alright, so, and we're trying to find the sum. So this is going to be arithmetic, so S of n, we're going to use the formula S of n equals n over 2 times the quantity a sub 1 plus a sub n. Alright, so our a sub 1, so we're summing from 1, the even numbers from 1 to 1,000. So the first even number that we get to is 2. So a sub 1 is going to equal 2. A sub n is going to equal 1,000. So the sum is going to equal 500 over 2 times the quantity 2 plus 1,000. So then that's 250 times 1,002. So then that gives us 250,500. So the sum of all the even numbers from 1 to 1,000 is 250,500. Alrighty, so last question on Test 5 test review. So Krispy Kreme makes a new fruitcake donut that is so popular they decide to sell it year-round. Ew, I can't stand fruitcake. So in December, the month of its debut, they make $15,000 on the sale of the donut. Thanks to social media, they are seeing an increase in sales of the fruitcake donut of 8% per month. So based on this, our initial value, so our a sub 1 is going to be 15,000, and this is a geometric sequence because the popularity of the sales is increasing by 8% each month. So each month the sales are increasing by 8%. Alright, so our a sub 1 is 15,000 and our R value is 8%, so it's increasing 8% each month. So they're making their regular sales plus an extra 8% each month. So they're actually selling 108%. So their sales are increasing by 108%. Because 100% would be their regular sales. And then the 8% is the increase. Alright, so then we're going to change this percentage to a decimal. So decimal points back here. We multiply by we divide by 100. So moving the decimal point 2 places to the left to change it into a decimal. So R equals 1.08. Alright, so we need a recursive formula for the geometric sequence. So recursive formula is always a sub n plus 1 equals a sub n times r. So in this case, so this part doesn't ever change. The only part that changes is what you're multiplying by. So in this case, our R value is 1.08. So a sub n times 1.08. So that is our recursive formula. Alright, so in B, it's asking for the explicit formula. So for a geometric sequence, the explicit formula is always a sub n equals a sub 1 times r raised to the n minus 1 power. So in this case, we're going to have a sub n equals, our r is 15,000. Well, my bad. Our a sub 1 is 15,000. Our r value is 1.08. So 15,000 times 1.08 raised to the n minus 1 power. So that is our explicit formula. Alright, so last question. Find the sum of the first year sales. Alright, so it's increasing by 8% each month. And there are 12 months in a year. So we're looking for S sub 12. Alright, so the formula for the sum of a geometric series is S sub n equals a sub 1 times the quantity 1 minus r to the n power over 1 minus r. So we're going to be substituting the values into here. Alright, so our a sub 1 is 15,000. So 15,000 times the quantity 1 minus r. Our r is 1.08. Our n is 12. And we're going to divide this by 1 minus r. So 1 minus 1.08. So then we're going to type this in the calculator. So 15,000 times 1 minus 1.08 raised to the 12th power. We're going to close the parentheses. So this is our numerator. And we're going to divide by 1 minus 1.08. So the sum for the first year sales is $284,656, and since we're dealing with money, we're going to round to the hundredths place. So remember, we look to the right. So if the number is 5 or greater, then we round up. If it's 4 or less, we round down. So it's 6, so the 9 rounds up to a 10. So 0.90. So $284,656.90 is the total sum of the first year of sales. Alrighty, so this concludes the test review video for test 5. Don't worry about questions 9 and 10 on the test review. We haven't covered this yet, but we'll be covering that probably in the next unit. So don't worry about it, and good luck on your test on Thursday.